Hey, people's Saturday still, but I'm going to do a video on density, sinking, or floating of liquids. The one that we did for solids took less than 10 minutes, so this should be real quick too. Should be easy for you. So let's see what we can do with it. All right. All right. So Alex, yeah, but that's very nice. The sun's next to me too. It's something for like a castle or something. All right. The previous one we looked at it. A substance that weighs less than the volume of water, it's less dense, and if it's more than the volume of the water, then it's more dense. Today we're going to look at liquids that are more massive than the density of water. Therefore, they're going to sink or they're going to float. Candles placed in alcohol and water.
Here are 2 wax candles and a cup of alcohol on the left and a cup of water on the right. Will the candles float or sink? Observe what happens, which one floats, and which one sinks. Remember, the candles are identical. Why does one float and one sink?
Okay, so the candle floated in water and sank in alcohol. This demonstration makes you think that water is more dense or less dense than alcohol. What do you suspect? All right, so the candle floats in alcohol or in water, but it sinks in alcohol. That means the alcohol is less dense than the water. Alcohol is less dense than the water. Let's see if I'm right. Two candles are made of the same material, have the same density. The cup with the cup with the floating candle contains water, and the cup with the sinking candle contains isopropyl alcohol. In the next section, we'll look at investigate whether water is more or less dense than alcohol. Okay. All right. Let's take a look. Water or alcohol? Which one weighs more? Prediction: alcohol weighs less than alcohol has less mass than water.
Let's compare the mass of equal volumes of 2 different liquids. On the left we have alcohol and on the right we have water. There are equal volumes of these 2 liquids. Which liquid do you think will have more mass?
Water. Yeah.
Take a look at the balance. With equal volumes, which liquid has more mass? Is it alcohol or is it water?
Okay. In the video, an equal volume of water and alcohol were placed on opposite ends of the balance. Which one weighed more? The water. Equal volumes of 2 substances are compared. You can figure out which one is more dense, water or alcohol. That would be the water. Okay. Water is more dense. Equal volume. All right, cool. All right, look at the illustrations of water, oil, and alcohol. So water is most dense, oil, and then alcohol. All right. If you weighed equal volumes, oil, water, and alcohol, what do you think would be the most dense? That would be the water. If you, same thing again, least dense, that would be the alcohol. All right. Put the 3 of them in there. What would be the order of least to most dense? That would be alcohol, oil, water, AOW. AOW. Yeah, cool. All right. Please copy down a chart and put it into the thing. This is where we're going to use the Google Sheet. All right. So we'll grab another one. Sheets. Like that. Pop this over. Get a new one. So we're going to go volume in milliliters. All right. Mass of both in grams. Mass of empty cylinder, grams. Mass of the liquid in grams, and then density of liquid in grams per centimeter cubed. All right. Now we're doing water, 50 mils. So it's going to be 50, 50, 50. All right. I'm going to add another. We're going to add a insert a column right there. This is going to be water, alcohol, and oil. All right. And the mass of the empties is 15, 15, and 15. All right, this is what they gave us. All right, let's figure it out.
Why does oil float on water? And why does alcohol float in oil? In this activity, we'll take actual measurements of the mass and volume of these three liquids in order to calculate the density for each liquid. We'll fill out the chart as we go along. First, let's find the mass of the empty graduated cylinder. Record this value in your chart.
We got that, it's 15.
Now, water will be added to the graduated cylinder up to the 50 milliliter mark.
That's a 1-to-1
For all
ratio,
three liquids,
remember.
we will use 50 milliliters, although the quantity of the liquid doesn't matter
So it
because
should
the
be 50
mass
and
will
50.
change accordingly.
So it'll be 50 and 15, so it's 65.
Record the mass of 50 milliliters of
Yeah.
water plus graduated cylinder in your chart now. Now we will repeat this trial with alcohol. "50 milliliters of alcohol is added to the graduated cylinder. Record the mass of 50 milliliters of alcohol and a graduated cylinder in your chart now.
58.8.
Finally, this trial will be repeated with oil. "50 milliliters of oil is added to the graduated cylinder. Notice how it is carefully poured so that it won't splash up on the walls. It may look like there's more than 50 milliliters here, but that's just because of our camera angle. Record the mass of 50 milliliters of oil in a graduated cylinder in your chart now.
60.6. Okay. What is the mass of 50 milliliters of alcohol? It's 58.8. Mass of milliliters of alcohol. All right.
Change accordingly. Mark. Now we will add it to the mass of 50 milliliters of alcohol and a graduated cylinder in your
58.8.
chart now.
Oh yeah, because I gotta subtract it. See, you gotta remember, guys. My bad. All right, so this is what I'm gonna get is I'm gonna get equals this minus this. Boom, and then come down. All right, 43.8. See, you gotta pay attention. All right, so alcohol is 43.8. Right? Yeah. All right. Let's make this a little bigger. All right. Just a little bit. All right. Now, what's the density of the oil in the video? All right, the density is the liquid. Nope, this one. Divided by the volume right there. right, so that's going to be 1. I drag this down. It's going to be 0.876. The density of the oil, 0.912. Is that right? 0.912. Yep. Okay. Oops. All right. So let's see what I got. 0.88, 0.91. That's good. We're good. How did the chart work? It was great. Once I figured out, I remembered to subtract out the empty cylinder. My numbers worked correctly. All right, that's just for me. You probably would have had a better one because you would have remembered that one. All right. Why does water float, oil float on water? Compare the structures and appearance of oil and water molecules in the models to help you answer. All right, so the hydrogen is smaller. The connections are hydrogen and carbon. And carbon is smaller than oxygen and hydrogen, so that this is heavier than, so this has more mass than this one. Oil has less mass than the water. Why does alcohol float on oil? Because it has carbon and less oxygen, and the carbon is bigger, and there's more of it over here than there is with the oil. Yeah, that's right. Yes. Carrot slice from fresh water versus salt water. Okay.
Here's a cup of fresh water. We'll add a carrot slice to the fresh water.
It sinks.
You'll notice that the carrot sinks in fresh water. This means that the carrot slice is more dense than fresh water. Now we'll add table salt to the water and stir to make sure the salt dissolves quickly. Watch what happens to the carrot slice. The carrot slice is now just barely floating.
Because it's sitting on top of the salt.
So the carrot slice is less dense than salt water. For the rest of this video, we'll play around and change the density of the water solution in the cup. First, we'll add more fresh water to the cup. The carrot slice will always have the same density, but the solution in the cup will vary. The more fresh water we add to it, the lower the density, and the more table salt we add to it, the higher the density. Right now, we're adding fresh water to the cup, so the density of the solution in the cup is dropping. Eventually, if we add enough fresh water to the cup, the density of the water in the cup will be lower than the density of the carrot slice, and the carrot slice will sink.
Cool.
Now let's add more salt to the salt water
Yeah, more
solution.
salt to it and it's going to make it go up.
This time, instead of adding so much salt that the carrot floats, we'll aim to add just enough salt so that the density of the solution and the density of the carrot are equal.
Suspended.
When this is the case,
So
the carrot won't float to the top and it won't sink to the bottom, but it'll remain suspended in the equal density fluid.
Cool. Carrot, in the video, the carrot slice sinks in fresh water. Does that mean that the carrot is more dense or less dense than fresh water? It's more dense than fresh water. After the salt's added in, this carrot slice floats. Explain what you think happened that made the carrot slice float in salt water. The salt concentration changed the density of the water, and it was more dense than the caret, whose density remained the same. Now, the way I said it is because this one changed and this one remained the same, so I made sure that I answered both questions. Then, is it Dan? Dan? Okay. What would happen if equal volumes of salt water and fresh water were compared on a balance? The fresh water would be less dense than the salt water. The fresh water is less dense than the salt water. So the balance would sway towards the salt water. Okay. All right. That's basically it. This one was a little bit more contentious, but it should be relatively not that hard to do. I would say I'm good with this one. It just made me like answer a couple extra questions. Hopefully you have an easy go with this one and that you can get it done relatively fast. I just found out that 11:34 a.m. on November 7th, 2020, President Joe Biden has become the 47th president. It's kind of cool. History.